is pre-calculus big quiz little test review for sections 1.5 to 1.8, the portion of the chapter on quadratic equations. So I'm actually going to do my work on a separate sheet of paper. So I'll show you that sheet of paper. But number one is I 24th, and we calculate I in 4, and 24 is 4. Therefore, I to the 24. Number 2, we have 5 plus 3i quantity squared. So we need to rewrite it 5 plus 3i times 5 plus 3i. We have to multiply it out like that. We get 25 plus 15i plus 15i would be plus 30i, and then plus 9i squared. I had some people leave it like this on the quiz we took over this section, but this has to be simplified. Okay, that's 25 plus 30i minus 9, and 25 minus 9 is 16. And technically it should be written in the form 16 plus 30i. Okay. Number 3, we have 5 plus 3i times the quantity 2 minus 5i. So multiply that out, 10, and then we're going to get minus 25i plus 6i is minus 19i, and then minus 15i squared. And again, that needs to be simplified. 15 minus 15i squared will become plus 15. I squared is negative 1, and minus negative is plus. So 10 plus 15 is 25, minus 19i. Right along, number 4, 3 plus I over 3 minus I. So we have to rationalize the denominator, and we multiply by the conjugate to do that. 3 plus I over 3 plus I. And I get, in the numerator, I get 9 plus 3i would be plus 6i, and then plus I squared over 9 plus 3i minus 3i, the middle terms drop out, point of doing this, and then minus I squared. So that numerator will turn into 8 plus 6i. That denominator will turn into 2. And now I can reduce everything by 2, which I need to do. Yeah, I wouldn't leave my answer like that. So 4 plus or thinking quadratic formula, 4 plus 3i all over 5. And number 5 is the quantity 9 minus 5i minus the quantity 14 minus 7i. And what we need to do, just a simple subtraction from that first set of parentheses, really are not necessary, but they're there. So we will deal with them, and I'm going to deal with them by getting rid of them. 9 minus 5i, and I'm going to distribute that negative, so it'll be minus 14 plus 7i, and then combine my terms. 9 minus 14 is negative 5, and negative 5i plus 7i is plus 2i. Number 6 has 5 plus I square root 2 over 1 minus I square root 2. And so, again, we have to get the radical and the I out of the denominator. And to do that, we're going to multiply by the conjugate. The conjugate would be 1 plus I square root 2 over 1 plus I square root 2. So in the numerator, I'll multiply that out. 5 times 1 is 5. And then it'll be plus 5I square root 2. Because this one has so much terms and stuff, I'm going to go ahead and write it out like this. And then plus would be I square root 2. And then plus the square root of 2 times the square root of 2 is 2. I times I is I squared. So that'll be plus 2I squared. The denominator will have 1. And then we'll have plus I square root 2 minus I square root 2. So those middle terms drop out. Then it'll be minus the square root of 2 times the square root of 2 is 2. I times I is I squared. So minus 2I squared. In the top, that becomes 5 minus 2 because of the I squared. So I'm going to have 3 plus 6I square root 2. And in the bottom, that's going to become 1 plus 2, which is 3. Now I can reduce that, take a 3 out of everything. So my answer would be 1 plus 2I square root 2. The denominator is on. Okay. For 7, we have I to the 75th. I think the closest multiple of 4 would be I to the 72. Then that would leave us with I to the 3rd, which is minus I. We have plus 3I, parentheses, plus 5 minus 2I. Again, just a adding like terms. The first set of parentheses are not necessary. The second set of parentheses are not necessary. In that other problem, the second set of parentheses are necessary because I had a minus here. But for this one, if I wanted to, I could just write it just like that. And then combine like terms. 6 plus 5 is 11. Plus 3I minus 2I is plus I. That's it. For 9, 7x squared minus 5x minus 2. Use a quadratic formula. I think that would factor, but I know a lot of you have been using the quadratic formula instead of trying to factor, which is fine. So I'm gonna do it that way. So x equals the opposite of b plus or minus the square root of b squared minus 4 times 7 times negative 2 all over 14. And that gets us 5 plus or minus 25 plus 56. Oh, wow, that's 81. Should have known that. Over 14. Okay. And now that is 5 plus or minus 9 all over 14. And again, some of you on the quiz over this section, this was section 6, left your answer like that. Not acceptable. Obviously, we can take 5 plus 9 and divide by 14. We can take 5 minus 9 and divide by 14. This is 14 over 14. So x equals 1. This is negative 4 over 14. So x equals negative 2. When it comes out, when the radicand here is a perfect square, and we end up getting answers like this, that tells us for sure it would factor. If we would have gotten an irrational number here, obviously it wouldn't have. Okay. If you're more into the factoring, well, you know, if you're into the factoring, you know how to factor that. So 1 and the square root of 3x plus 6 equals 2x plus 1. We square both sides to get rid of the radical. So we can solve this easily. So we square both sides. That gives us 3x plus 6 over here. And again, to square this means we're going to take 2x plus 1 times 2x plus 1. And we have to FOIL that. We're going to get a trinomial. So it's going to be 4x squared plus 2x plus 4x plus 1. And then I'm going to set it equal to 0 because that's how we solve a quadratic equation. And it's going to be 4x squared. 4x minus 3x would be plus x, and 1 minus 6 would be minus 5. And that's going to factor, because if it doesn't, that means we're plugging in an irrational, ugly-looking number to figure out if it works. So I'm pretty confident that this is going to factor. So I'm just going to go right, I'm not going to use the quadratic formula. I'm going to do 4x squared, negative 5, and x. We use 4x and x, 1 and 5 gives me 4x and 5x, and I need the 4 negative to make that work. So the 1 is negative. And so my answer here is 4x, quantity 4x plus 5 times the quantity x minus 1. That's 0 equals that. So we set each one of those equals 0. We get x equals negative 5/4. We get x equals 1. And we have to plug them back in. So if I plug in 1, I get 3 plus 6 is 9. Square root of that's 3. And then over here I get 2 times 1 is 2 plus 1 is 3. So that one works. Negative 5/4. I have to write some stuff down here. 3 times negative 5/4 is going to be negative 15 over 4 plus 6, 24 over 4. That is 9 over 4. Okay. The square root of that is 3 halves. So on the left-hand side, we have 3 halves. On the right-hand side, we're going to take 2 times negative 5/4, which is going to be negative 10, or actually we could make it negative 5 halves, plus 1, 2 halves. I get, on the right, I get negative 3 halves. So we throw this answer out, we keep this one. And number 12. Graphing a parabola. We are in standard form. Y equals 2x squared minus 8x minus 1. And like I say, I like to find the vertex first. I use the opposite b over 2a. Then I plug that in to find y. So 2 times 2 squared minus 8 times 2. See, that's going to be 8 minus 16 is negative 8, minus 1 is negative 9. 2 times 4 is 8, minus 16 is 8. Yep. So the vertex is at 2, negative 9. That makes the axis of symmetry x equals 2. The domain is all real numbers. I'll come back to the range once I look at the graph. My x-intercept, find, and my y-intercept is 0, negative 1. Okay? I did not bring home any graph papers, so I'm just going to draw the graph here. Nine, 4, 3, 4, 2, 3, 4, So 2, -9, all the way down here. And then I have a 0 at -1, which is here. And then using the axis of symmetry, that other point should be here. I need to find the points in between there. Like if this is at 2. So a good point to plug in would be 1. But moving the furniture, so I'm just going to slide everything to the left here a little bit. Wasn't sure you were seeing that with the sun in my window there. So I should plug in 1 to get another point there. If I plug in 1, I'm going to get 2 times 1 is 2, -8 is -6, -1 is -7. So 2 up from my vertex. Then that puts the other one right here. That is good looking parabola. Oops. That one a little bit. So now I can tell my range is y is greater than or equal to -9, or -9 to infinity if you're getting into that bracket notation. X-intercepts, obviously I don't think they're rational. I think they're irrational. So 0 equals 2x squared minus 8x minus 1. So x is 8 plus or minus the square root of 64 minus 4 2 times 1 over 4. Let's see. 8. And this should be -1. Sorry. All right, 40. Yep. So 64 plus 8 is 72. And some of you are simplifying this in a way that I don't. And then you're leaving perfect squares there. Like you might simplify this and end up with the square root of 12 at the end. The square root of 12 still contains perfect square factors other than 1. And the way to be honest, I've been doing this long enough that I can actually figure that out in my head, because I know it's 36 times 2. The square root of 36 is 6. And that method is good as long as 36 is the greatest of the perfect squares that goes into 72. 9 is also a perfect square that goes into 72. And if I choose to use 9 and not 36, there's going to be a perfect square left in there. So the foolproof way is to do the prime factorization. 36 or 72 is 2 times 36. That's 2 times 18. That's 2 times 9. That's 3 times 3. And then what I do is wherever there's 2 alike, which is there, 1 comes out, 1 disappears. So I got a 2. Here's 2 more alike. 1 comes out, 1 disappears. I got a 3. And there's a 2 left. That method is foolproof. Okay. So this is plus or minus 6 square root 2 all over 4. Then again, on that quiz we took over, the section where we worked on the quadratic formula, some people left their answer like that, and you can't. It reduces. You have to reduce that. And so we reduce it to everything by 2. So we get 4 plus or minus 3 square root 2 all over 2. And those are our x-intercepts. So we write 4 plus or minus 3 square root 2 over 2 comma 0. It takes care of both of them. And people have asked, how do I graph that? I don't know. It falls in there somewhere. I don't know where it is. That's fine. Those aren't points. Those aren't points that we're particularly interested in. We like to know them, and if we worked it into a problem, it would probably factor out better than that, and the x-intercepts would be more interesting. But for a lot of the problems that I make up, you're going to get irrational. So number 13, we have y equals. We're in graphing form now, or some folks call it vertex form. X plus 3 quantity squared minus 4. Our current Algebra 1 book calls it vertex form, which is graphing form, vertex form. The main point of it is that I can look at it and I can tell you the vertex. That's why I think the Algebra 1 book is our newest textbook in the building right now. So we can call it vertex form. So the vertex is the opposite of what's with the x, and the same sign as what's out here. So our vertex for this problem is -3, -4. It opens up because there's no negative out front there, and so our axis of symmetry, x equals -3. Remember, it has to be x equals -3. If you just put -3 there, it's wrong on all parts, because the axis of symmetry is a line. And so to write the equation of it, we have to write the equation of a line. And then we want to be able to find the domain is all real numbers. The range we'll look at once we look at the graph. Then we have the x-intercepts, the y-intercept. And I think the disadvantage of graphing form or vertex form is that you can't look at it and say what the y-intercept is. It's not hard to find. I just let x be 0, and 0 plus 3 is 3, squared is 9, 9 minus 4 is 5. Now we are ready to look at a graph. That wasn't very straight. Showing off the count doesn't college show off something. So the vertex -3, -4, right here. Y-intercept 0, 5. It's way up here. Let's see, that's 1, 2, 3. Over here. Here. And again, that's just a little bit too much space in between. What point should I plug in? Well, I'm at -3. Right next to it is -2. So why not plug in -2? -2 plus 3 is 1. And I'm sorry. No, that's right. -2 plus 3 is 1. Squared is 1. And 1 minus 4 is -3. Right there. Right there. I'm going to go ahead and plug in -1. -1 plus 3 is 2. 2 squared is 4. And 4 minus 4 is 0. We just found one of the zeros, and we didn't have to do any algebra to do that. So other 0 then would be right here. So our x-intercepts are -1, 0, and 1, 2, 3, 4, 5. -5, 0. Okay, that was nice. You're welcome. Then, right, there's our parabola. Obviously, the range is from here up. So y is greater than or equal to -4. And then just so in case the one on the test doesn't come out like that, where we find the zeros when we graph it, find the zeros or the x-intercepts where that y be 0. And then what I do when we're in graphing form is I just slide the 4 over here. So I'll add 4 to both sides. And then take the square root of both sides. So plus or minus 2 equals x plus 3. And then subtract 3. Negative 3 plus or minus 2. And negative 3 plus 2 would be negative 1. Negative 3 minus 2 would be negative 5. And that's what I got up there. That's everything, right? Okay. I just noticed when I was looking, I was so excited to get to graphing the parabolas, I skipped number 11. So I'm going to go back to that before I do number 14. If y equals 9 minus x squared and y equals 10 minus 2x. And we're supposed to solve this for the points of intersection if there are any. So what I do is I set them equal to each other. Substitute 9 minus x squared equals 10 minus 2x. I don't like my x squared to be negative, so I'm going to move everything to the right. So it's going to be 0 equals x squared minus 2x, and then plus 1. Could it be that that factors? I think it does. Sure. X squared, 1, and again, thank goodness, because if it didn't, we'd be plugging that irrational number into one of these equations to figure out what the y value is. This would be x times x, 1 times 1, and they would both need to be negative to make, so x minus 1 times x minus 1. That tells me a couple of things, several things really. It's quite interesting. It tells me, one, that x equals 1 and x equals 1, and that's when we get that, we have a double root situation. That means that this line is tangent to this parabola at 1, where x equals 1. If we were to graph these, this line would be tangent to this parabola at x equals 1. And I don't know, I just find that very cool. So now I just have to plug in 1. I'm going to plug it into this equation, and I get 10 minus 2 is 8. So these only intersect in one point. They intersect at the point 1, 8. And that tells me that the line is tangent to the parabola at that point. Okay. Lastly, bada bing, bada boom, number 14, we have zeros at negative 4 and 2 and a maximum value of 2. Okay. So I think I'm trying to think here. I think what we want to do, because I have some unknowns here. This is the y coordinate of my vertex. And so if I use vertex form, graphing form, I would plug in 2 there. Then this gave me 2 points. It gave me the point negative 4, 0. It gave me the point 2, 0. Because those are the zeros, or the x-intercept. The value of y at the x-intercept is 0. So what I have to do, because they did not give me the full vertex, is I have to use this to write one equation, use this to write another equation, and then solve those equations simultaneously so that I can figure out what A and H are. Okay? I'm going to take this and I'm going to plug in the point negative 4, 0. So y is 0, A times negative 4 minus h, quantity squared, plus 2. And 0 equals A times 2 minus H quantity squared plus 2. And so now, multiply that out. I'm going to get 16 minus, plus 8H plus H squared plus 2. And over here, I'm going to get A times 4 minus 4H plus H squared plus 2. Okay? And I am going to set them equal to each other. Be 16A plus 8AH plus AH squared really getting me nowhere. I don't have a good feeling about this. If did y equals x plus 4 would be y equals a x squared plus 2x minus 8. Oh, shoot. Sorry, guys. This is the very reason I showed you in class that one day. I have x zeros at -4, that's here, and 2, that's here. The x coordinate of the vertex will be halfway in between. So, 1, so the x coordinate of the vertex is at -1. So I do know what h is. H is -1. I made this way harder than I should have. So then I can continue on with this idea if I want to, that I can plug in the point rather than going back to this. This is what I would do, and I would like I said, that gives me x plus 4, that 0 gives me x minus 2, the a in front because that gets us the specific parabola, and now I can plug in the vertex, which is -1, 2, to figure out what a is. So -1 squared plus 2 times -1 should be -2 minus 8. So 2 equals a times -9, or 2 equals -9a. So a is -2. So our answer is y equals -2/9, and then times the quantity x squared plus 2x minus 8. And I think when I did this one, where I did this one, I left that out there. I said don't multiply that out. Okay, and it wasn't this one exactly. I think we got 1/5 or something for A. It's just going to be messy. So Just leave it like that. And sorry about my brain lapse there. It happens. So anyway, that's it. Come see me if you have questions. And very similar to the test. Number